All right, so now let's take a look at reflections. Now, a reflection is a flip over a line called the line of reflection, where each point on the image is the same distance from the line of reflection. So as you can see on this image here, we have our pre-image, and our image here. And as we can see, this image is reflected across this line, which is the y-axis. Okay, so let's take a look at some common lines of reflection. We have the x or the y-axis, and so here we have our x-axis, which is our horizontal axis, and we have our y-axis, which is our vertical axis. And in this example here, of course, these figures are reflected over the y-axis. Okay. We also have vertical and horizontal lines such as x equals 1 or y equals -2. X equals 1 will simply go through the x-axis at 1. So trying to draw a straight line here, but it crosses the x-axis at 1. So that would be a vertical line of reflection. And then y equals -2. Trying to draw a straight line here through y equals -2. And that is, of course, a vertical line. And we also have diagonal lines such as y equals x and y equals -x. So now let's take a look at some examples here. It says triangle ABC with vertices A, -4, 2, B, 4, 7, and C, 5, 1. So we already have our pre-image here. And so we want to reflect that line, or this figure here, across the x-axis. And so what I'm going to do, I'm going to simply take each one of my vertices and count the amount of spaces from the x-axis. And so I'm going to start with A. So I have A, this is at -4, 2. But I'm going to count, so this is 2 spaces away. 1, 2 spaces away from my x-axis. So I'm going to count in the opposite direction. 1, 2. That is going to be my A prime, and that ordered pair is -4, -2. All right. I'm going to do the same thing with B and C. So B, it is, let's see, 1, 2, 3, 4, 5, 6, 7 spaces away. So I'm going to count 7 spaces in the opposite direction for my x-axis. 1, 2, 3, 4, 5, 6, 7. So that would be right here. I'm going to label that B prime. And that new ordered pair would be 4, -7. All right. Same thing with C. C is 1 space away from my x-axis, so I'm going to count 1 space away in the opposite direction. Label that C prime. I'm going to try to draw straight lines to connect them. Let's see. Kind of straight, but not that straight. All right. There we go. That is my image. All right. And so my C prime, that ordered pair is 5, -1. Now, what do we notice about the ordered pairs here? Well, we notice that the signs of the y values have changed. So look here. In our original image, or in our pre-image, our y value was 2. It has changed to a -2. Here, it was 7, it has changed to a negative 7. And here it was 1, it has changed to a negative 1. So a trick you could use is, if you don't have a coordinate grid, if you want to reflect a figure across the x-axis, simply change the sign of the y value of the coordinate. So in this example, I'm going to reflect this rectangle over the y-axis. And so I have my ordered pairs here, my vertices, 1, 2, Q is 2, 5, R is 8, 3, and S is 7, 0. I'm going to do the same thing I did with reflecting the line across the x-axis, except with the y-axis. So for P, I'm going to simply count the spaces away from the y-axis, and that P is 1 unit away, so I'm going to go in the opposite direction and label that P prime. And that ordered pair for P prime is negative 1, 2. Same thing for Q. It is 1, 2 units away, so in the other direction to the left, 1, 2. That is Q prime, and that ordered pair is negative 2, 5. R right here, and that is, so it's at the end here. I'm just going to count the spaces at the top. So 1, 2, 3, 4, 5, 6, 7, 8. So R is 8 units away. So again, 1, 2, 3, 4, 5, 6, 7, 8. Making sure it's in the same position, just on the other side. That is my R prime. And that ordered pair is negative 8, 3. Last one, I have S. So if R is 7 units away, S will have to, 8 units away, S will have to be 7 units away. So I'm going to count 1, 2, 3, 4, 5, 6, 7. Right here, that would be my S prime. And again, attempt to draw straight lines. All right. And again, that is my image. And S prime would be negative 7, 0. So what do we notice about the ordered pairs? Well, if you look here, my X value is 1, it changed to negative 1. X value for Q is 2, it changed to negative 2. R was 8, changed to negative 8. And S is 7, it changed to 7. So we can conclude that we want to change the sign of the X value of the coordinate when we are reflecting across the y-axis. Okay. So we have another example here of reflecting over vertical or horizontal lines. And so we have our image here, which is a triangle with our given vertices. And our line of reflection here is x equals 4. And so we just draw a straight line through 4 on our x-axis. And that is going to always be a vertical line. So x equals 4. And I'm going to do the same thing as I did with reflecting across the x and y axis, which is just simply just count the spaces from that line. So what L is here, I'm going to count over one space. That's my L prime. Yeah. Okay. For J, from x equals negative 4, x equals 4, I'm sorry. 1, 2, 3. So 3 units away on the other side. 1, 2, 3. And that is J prime. And last I have K, 2 units away. 1, 2. So I'm going to count back 2 units in the other direction. And that is my K prime. So I'm trying to draw the image. Again, my lines are not straight at all, but it looks somewhat like a triangle. important piece is that I know that my ordered pairs are exact. And so I just want to write my new ordered pairs here. So J prime would be 7, -1. Let's look at L. L prime for my image would be 5, -2. And then K prime would be 6, 3. So we simply just count the spaces from our line of reflection and then count back in the opposite direction. So now we're reflecting over some diagonal line, y equals x. And it says triangle XYZ with vertices -5, 2, -3, 4, and z -1, 1. We want to reflect that figure across the line y equals x. Alright, so that line has a slope of 1 going straight through the origin. And now I've already reflected that shape across the line y equals x. And what do we notice? Let's analyze the vertices here. Our new vertices are -2, 5, 4, -3, and 1, -1. So let's just analyze from x to x prime. What happens with our x and y values and what happens to their signs? Well, I see I have a -5 and a -5 here, but instead of it being in my x value here, it's in my y value. Right here, -2 has changed to my x value. Same thing. -3, 4 has changed to 4, -3. -1, 1 has changed to 1, -1. So our pattern here is we want to flip the x and y values of the ordered pairs. So whenever you reflect an image across the line y equals x, you simply want to just flip the x and y values. Now let's reflect over the line y equals -x. So slope of -1 going through the origin. And I've already have the image here and our new ordered pairs. What do we notice about these ordered pairs? Let's look at S. -1, -6, it changes to 6, 1. What happened? The x and y value flip, but what also happened to the signs? The sign changed. Let's look at T. T is 0, 3. Now it is -3, 0. U is 3, -4. Now it is 4, -3. So as you can see, our x and y values have flipped, but the signs also change. So as you can see here, that 3 becomes negative. That -4 becomes positive. So when you're reflecting over the line y equals -x, not only do you flip the ordered pairs, but you change the sign as well. So things to remember. For our line of reflections, if it's reflected across the x-axis, you simply want to change the sign of the y value of the coordinate. If you flip it across the y-axis or reflect it across the y-axis, change the sign of the x value of the coordinate. For y equals x, flip the ordered pair x and y. And for y equals -x, you want to flip the x and y coordinates, but also change the sign. Okay, we've reached the end of our lesson on reflections. Thank you for learning with me. If you want to see more videos about transformations, just click that playlist and you will see videos on translations, reflections, and dilations. And don't forget to subscribe.